Hi all. Now I'm going to explain how to charge a battery automatically using an SCR by trickle charging method. In my previous video, I've explained to charge a battery automatically using an SCR. Now this is the next way of charging a battery continuously. I'm Dr. V. Kritika. Let us check the circuit. Like the previous circuit I've explained in the previous video, we have the AC supply and the transformer and the center tap rectifier to convert the AC to a DC. So this is my single phase AC supply. This is the transformer step down type converting 230 volt, changing from 230 volt to 12 volt. Center tap secondary winding 12 volt 0 and 12 volt here. We have two diodes which perform the rectification operation, and we have two SCRs S1 and S2 for trickle charging process, and few diodes and few resistors, fixed resistors and variable resistor also available, a capacitor and a Zener diode. The specifications of each and every component is given here in the circuit itself. So you can make a try, you can get the components if you have and connect it, and you can check it in the prototype also. Now I'll explain how this trickle charging is obtained and the battery is charged using the SCRs. First, the single phase AC supply is passed on to the transformer, step down transformer. So 12 volt is available across the secondary winding. This center tap center tap rectifier operation is explained in my previous video. So the rectification is done by using the BY127 diode. During the positive half cycle, the upper diode conducts, whereas during the negative half cycle, the lower diode conducts. And anyway, irrespective of the diode conducting, we'll get the positive potential at this node and negative potential at this node. So we have DC supply, which is readily available to charge the battery now. AC has been converted to DC. Fine. Now let us try to understand how SCR1 is conducting and when it is conducting. Likewise, how SCR2 is conducting and when it is conducting. Because here the duration at which S1 and S2 conducts plays a vital role in charging the battery. That to trickle charging process. Okay. Initially, we have the positive potential here. So let us observe S1 first. This is the anode and cathode, and this is the gate of the S1. The battery is not charged. The other way of saying it is discharged. This is the condition of the battery. It is in discharged condition. So cathode potential will be very less compared to the anode potential of the S1. Or I can say, in other words, S1 anode will be having higher potential compared to the cathode potential of S1. So this in turn helps us to understand that anode is more positive compared to the cathode, and it is ready to conduct if we have a proper gate potential. So S1 is forward biased. The same positive potential flows through this resistance 47 ohms. It's a fixed resistor. So through this 47 ohms and this diode BY127, gate potential of S1 receives a proper potential, and because of which now S1 is ready to conduct. So S1 acts as a switch which is closed now. S1 is in conducting condition. Now once S1 is conducting, automatically the supply flows through this path and the battery gets charged now. Let us observe the other side of the circuit also now. During this condition, which means during the discharged condition of the battery, let us assume it as case 1. Okay, case 1 is discharged condition. At this position or at this condition, the voltage across this resistor, which is 1 kilo ohms 3 watts resistor, is less because it is in discharged condition, because this is the voltage available across this resistor, and so it is very less. This makes the Zener diode also not to conduct. Why? Because the voltage available or the threshold potential of the Zener is also very less. Why do we observe all this? Because once we receive a proper potential across the Zener, that is the voltage of the gate of S2. So during the discharged condition, the voltage across this resistor is low. Same for the Zener diode, and that is the case for the gate of the S2 also. Because this node is having a positive potential, and so anode is positive, cathode is negative of S2. If and only if we have a sufficient gate potential, S2 will conduct. But we don't have a sufficient gate potential to trigger the SCR, hence S2 is in off condition, which means it is not going to conduct now for the case 1. So during case 1, when the battery is in discharged position or discharged condition, S1 will conduct whereas S2 will not conduct. Fine. Now the battery, once the S1 is conducting, the battery is charged or it is getting charged. Now it will get charged and it will attain the maximum charging condition, fully charged condition. What happens now is we have to observe that this resistor will, the voltage across this resistor 1 kilo ohms 3 watts will have a sufficient potential so that the threshold potential of the zener is also high, which means it attains the proper potential, which means we can say there is a voltage available across the gate of the SCR2. What happens because of this? SCR2 is ready to conduct now. It's not ready, it will conduct immediately because gate is available and it is triggered, so it will automatically conduct. S2 will conduct now. Now we'll observe what happens to the S1. This is the case 2 condition where the SCR is in the fully charged condition. For the case 2, when the battery is fully charged, S2 is now conducting. Let us check what happens for S1. Here, this 47 ohms, two resistors, 247 ohms are connected, which acts as a potential divider, which in turn reduces the voltage across the gate. So what happens? The voltage across the gate of S1 is reduced, which makes SCR1 not eligible to conduct because it is not getting triggered, so it will not be conducting. Hence, during the case 2 condition, which means during the battery is fully charged, S2 thyristor will conduct whereas S1 is in off condition. Let us keenly understand that during the case 1 when the battery is discharged, S1 will conduct and S2 will be off, whereas when the battery is fully charged in the case 2, S2 will be conducting whereas S1 will be off. Okay, now we have to observe how the current flows if S1 is not conducting. There is an alternate path that is formed because of the diode BY127 and the 470 ohm resistor and a variable resistor connected here by which the charge is being given to the battery. The most important thing here to observe is the current required to charge the battery during the case 2, which is called as the trickle charging process, is very less compared to the main charging, which is the case 1. Trickle charging is a method by which we try to charge the battery irrespective of its intermittent use of battery, because of which there will be a self discharge or losses will be there. To avoid that, trickle charging is used. I'll give an example for you to understand this much better. If I have a car battery and if it is 48 amps, and if I use a battery charger of 4 ampere, to attain the full battery charged condition, I need 12 hours to do it. Instead, if I use the trickle charging method, it will be readily available or I can make use of the battery immediately whenever I want. So that is the advantage of opting the trickle charging process instead of the normal charging. So this is the difference between the charging of a battery that I have explained in the previous video and this one. In the previous video, we used only one SCR to charge automatically this battery, and once it is fully charged, we disconnect it. Whereas now we use the main SCR S1 to conduct, and it is used to charge the battery. Once it is fully charged, S2 is going to conduct, and it is just going to allow a minimal level of charging, minimal amount of current to flow to maintain the battery position or battery charge position. So that is why we use this S2 as 0.5 thyristor of S2 is having the parameter as 0.5 amps 50 volt, whereas you can notice for the thyristor one SCR S1 will have 3 ampere 50 volt. As I mentioned earlier, current required during the trickle charging process is very less compared to the main charging process. That is why there is a variation in the parameter. Hope you understood now how to charge a battery automatically, that too using trickle charging process using SCR. If you have any queries, put it in the comment section. Thank you.